So here's our review video for week 16. Remember, like I told you in class, this says non-calculator, but don't stress about that. Nothing that we're doing on this review requires a calculator, nor have we used a calculator at all this week. All right, so for all of these first few questions, we're talking about the end behavior of polynomials. And we talked about in class how we only need the very first part of the equations. The rest of the equation is irrelevant. So negative means that on the right-hand side, it's going to be going down. And then opposite comes because this highest exponent, or the first exponent that we see, is odd, which means that I'm going to have opposite end behavior. For example, the left side goes up while the right side goes down. Example 2, or question 2 rather, is very similar. I'm still just going to be looking at the very first part, and that is even, so I'm going to have the same end behavior. And it's a positive number, which means both sides, left and right, are both going to be going up. Questions 3 and 4 are very similar, where you would kind of start with that thought process. So this first term here is even, which means I need to have the same end behavior. And it's positive, which means I need both sides going up. Additionally, because there's a 4 there, that means I'm going to need to have 4 roots. So all I did to draw this was I just marked 4 different places, doesn't matter where they are, and I knew that my function needed to be going up, so that I just kind of drew a curve so that I would get a function that looked similar to that. Question 4 is very similar, except because it's odd, my ends need to be going opposite directions, and it's positive, so the right-hand side needs to be going up. And then I just made my 5 points and connected a line, kind of drew a curve so that I would hit all 5 of those roots. All right, questions 5 and 6, still kind of the same thing. Odd because these are going opposite directions. Negative because the right side is down. And then a possible equation would be negative anything, x to the third, and we say to the third because there are 1, 2, 3 roots here. 6 is similar, even because they're both opening upward, and then positive because they're up. And then I said x to the fourth because now technically there are 4 roots here. Remember, this one has a double root, so it's got 1 and 2, and then this root right here, since it bounces and turns, is actually 3 and 4. So that's why I'm going to have x to the fourth. You really just want to make sure that if you say even, you're picking an even number for that exponent. All right, and we're still on the same type of problem for 7 and 8. Odd because they're going opposite directions. Positive because the right side is going up. So remember, positive and negative, we just care about the right side. And then y equals x to the fifth because there are 1, 2, 3, 4, 5 times that it crosses the axis. Number 8, odd because it's opposite. Negative. Now sometimes people want to say this is to the first power because it's just hitting 1 time, but remember the first power means you would need to have a straight line, a perfectly linear line, and we don't. So that's why I'm going to say negative because it's going down on the right hand side, and then x to the third because that's the next odd number that will work. All right, this next section we're going to move into is talking about inverses. And you should remember that inverses means we're just going to switch the x and the y values with each other. So, these are both very easy. You're just plotting the original points. And then to get the new set, or the inverse, which remember is that f of negative 1, we're just going to be switching all the values. So 2, 3 becomes 3, 2, so on and so forth. And remember, when you plot this inverse over here, it should be like a perfect mirror across that diagonal line, which is y equals x. Number 10 is very similar, right? We've got our inverses over here. And then when you plot your inverses, you should see that they reflect perfectly across that line. Okay, 11 and 12 is where our inverses get just a little bit tricky. So I just want to talk through both of these problems. I gave you kind of 2 options. You could either switch the x and the y at the beginning, or you could switch it at the end. I'm going to switch at the beginning and then solve. So notice when I do that, this g of x, which would normally have been y, becomes an x. To get rid of this divided by 4, I'm going to multiply by 4 on both sides. And one thing I want to point out to you, I think I said this to many of you today, but when you multiply, this multiply by 4, since everything is divided by 4, they completely cancel each other out. So you don't actually have to multiply anything on this side. You're left with negative 3y plus 3. All right, and then I subtracted 3 from both sides, which is why I got 4x minus 3 here. And then it looks like I divided by negative 3. And then I divided each of these separately, which I probably should have written that a little bit differently, but I'm getting negative 4 over 3x, or 4 over negative 3, however you want to say that. And then negative divided by negative is positive, so plus 1. And remember, we write the inverse with the little negative 1 with the function sign. So 12 is very similar. We're just going to switch the x and the y. I added 1 to both sides here. And then to get rid of a half, remember, to get rid of any fractions, we have to multiply by that denominator. So I multiplied every single thing by 2 to give me 2x plus 2. Questions 13 and 14 are very similar. In 13 and 14, they're saying, are the given functions inverses? So they're basically asking, if you find the inverse of g, are you going to get this function right here? Is that the answer, is really what it's asking. So the first thing that I did, if you kind of come down here to my work at the bottom, the first thing that I've done here is I just switched my values. So x equals, and I changed the x to the y. And then I multiplied by 2 to get rid of denominators. So 2x equals negative 1y plus 3. Notice that these denominators cancel. All right. And then I subtracted 3 from both sides. And then my final step, which I did not write down, this says negative y, and I need positive y. So I'm going to have to divide everything by negative 1, which gives me negative 2x plus 3. But remember, the question said, was this f of x function that they gave us the inverse? And the answer is no, that's not the same answer that we got. So I said no. Question 14, same idea. I'm solving this first one to see if I get the second one as an answer. Now, one thing, if you kind of follow my work there, one thing that seems a little weird is I stopped here, and for some of you, you're going to say, well, that's very different than what you got there. But if we think about splitting this original answer up, okay, so I'm going to split that up. That becomes negative 1 over 3x minus 2 over 3, right, if I divide both of those. Well, if I divide my answer, I get 1 over negative 3x minus 2 over 3, which I hope that you see that those two things are exactly the same. Even though the negative looks like it's in a different spot, it's going to give you the same answer. Positive divided by negative is still negative. So that's why this is a yes. Okay, questions 15 and 16. It says find the inverse, so switch the functions, and then it says graph both. So remember this first equation right here, start at 5, up 1 over 1, down 1 backwards 1, down 1 backwards 1. All right, that's how I got my original function. And then my inverse, I just solved and graphed it. I draw this dashed line in the middle just to remind myself that whatever I get should be a perfect reflection over that line. Question 16. You can see my work here. I'm just working that out the same way. I actually had an error when I tried to graph mine. So the first one, you just graph by starting at negative 2 and going down 1 over 4. The second line I had counted incorrectly, but I started at negative 8. And since I don't have enough room to go down 4 over 1, I went up 4 backwards 1. So the actual correct answer is this line in black. That's the inverse. And hopefully you see that those two lines, and here I'll make them stand out for us. This inverse line and this original line do in fact reflect perfectly over this dashed line that I've got in the middle. Okay, on the bottom here, we're just talking about transformations. I don't really have work shown, but the biggest thing that you just need to remember is to name the vertex. The first one is like 0, 5, negative 6, negative 5, 0, 4, 1, negative 2. The first number is going to tell you whether you're going left or right. The second number will tell you if you're going up or down. And then this stretch, compression, and reflection. Stretch is going to be if you have whole numbers or numbers bigger than 1. Compression is going to be fractions. And then reflection is going to be negative numbers. And all of this vertical part here is when I'm talking about slope. So that's just considering these very first numbers for each of the problems. Notice on 20, for example, there is no slope here. So I can't select anything from that because nothing is happening to change the original pattern. Okay, one thing I want you to notice just on this page overall, I started making some mistakes. So see, notice on 22, I had to go back and fix this because I had tried to go backwards. One thing that I ended up doing, and I don't know if you can see these notes, I'll zoom in for you, is on 21 and 22, and I did this for all of them, anytime it was cube root, I was going to write for myself, so that means the little 3 is there. I wrote for myself 1 and 7 was the pattern. Cube root is 1 and 7, right? Anytime it was square root, so there was no number, for example, on 22, I wrote the pattern 1, 3, 5, 7 to remind myself which pattern I was supposed to be using so I wouldn't go too quickly and make mistakes. Remember also, when it's square root, you're only going to go forwards. So square root is 1, 3, 5, 7, and we go forwards only. Cube root is 1 and 7, and we go forward and backward. So if you need to make that note for when you come in for your test tomorrow, just kind of keep that in mind. So you can see on 21 here, I started at 4, 0, and then my pattern is 1 and 7, and I go both ways. So I went up 1 over 1. I would have gone up 1 over 7 if I had enough room. Down 1, backwards 1. Down 1, backwards 7. And because the arrows go both directions, my domain is all real numbers for both of them. Question 22, square root, all right, and this is starting at 0, 0. So I started at 0, 0 here. And now this time I have a 3. So I'm still going to use the pattern 1, 3, 5, 7, but now I'm going to go up 3 over 1, up 3 over 3, up 3 over 5. The other and there's not another direction. See, I keep messing myself up. I only go one direction for square roots. And then for square roots, our domain is not all real numbers like I had. Our arrow only goes one direction, so we actually have to indicate if it's greater than or less than. And since this is going to the right, I'm going to be saying greater than, and since it's going up, I'm going to be saying greater than for the range. Remember, the values you get for that are from this original vertex. Question 23, again, my starting point is 0, 0. This time I noted for myself that the pattern was 1 and 7 both directions. And my slope is 2, so I'm going to go up 2 over 1, up 2 over 7, down 2 backwards 1, down 2 to the left 7. And because I have arrows on both sides, that's going to give me all real numbers for both domain and range. 24, again, we've got cube root. This time I'm starting at -1, 0. So that's going to be my starting point right here. My fraction, or my slope, I'm sorry, is -1/2, and I'm doing 1 and 7. So I go down half over 1, down half over 7, up half, backwards 1, up half, backwards 7. So remember, you don't actually use this as a slope specifically. That's just how you count the up and down motion. You will always count by 1 or 7. And like I've said before, because it goes both directions, our domain and range are both all real numbers. 25. My vertex that I named, or my starting point, is going to be 3, 0. This is a square root, so I wrote for myself the pattern was 1, 3, 5, 7. So I start at 3, 0, and this time my slope is 2, so I'm going to go up 2 over 1, up 2 over 3. If I had room, I would go up 2 over 5, up 2 over 7. Only going one direction this time, which means now I can't say all real numbers as my domain and range. So because this is going to the right, it's going to be greater than, and the 3 is coming from the vertex. And because it's going up, it's going to be greater than for the y, and the 0 again comes from the vertex. Question 26. I noted my starting point. Inside's the opposite, outside's the same. I also noted for myself the pattern since it's square root. And the last thing I need to know is that I'm counting by 1/2 this time. So I'm going to start at +1, -2. And then I'm going to go up 1/2 over 1, up 1/2 over 3, up 1/2 over 5, up 1/2 over 7. And then I need to name my domain and range. It does not go both directions, so it cannot be all real numbers. So because I'm going to the right, this is going to be x is greater than. And because I'm going up, it's going to be y is greater than. Remember, that all has to do with kind of the direction the pattern is going, not where you're starting.